Hello everyone, welcome to Scalers YouTube channel. My name is Aditya. I'm currently working as a data architect at PepsiCo. In the first module, we are going to discuss about the basics of data engineering, difference between big data and data engineering, how big data came into the market, and the 5 E's of big data. We'll also discuss about the pay scale of an average big data engineer and how one can get started with the initial basics of big data. Before deep diving into the session, do not forget to check out the Scalar masterclasses taken by the leading industry expert at Scalar event page. The link is in the description below. If you want to watch similar content in future, please do subscribe to Scalar YouTube channel. And now let's get started.
So, what is data engineering? Data engineering is a concept or a kind of branch related to data where the engineers build systems which are used to collect, store, and process data. So basically, engineers as a team work together to fetch data from different source systems. When I talk about fetching the data, it's basically collecting the data in the proper format, storing the data in the required volume, and then processing the data as per the business requirement or the use case scenario. But why data engineering is so much of important these days? As you see, all the devices around you, be it your watch, be it your Wi-Fi, your TV, anything which is running on the internet, is somehow storing some data, consuming some data, or using some data in some of the forms for a business analytical purpose. So companies these days utilize a lot of data which is coming out of these devices. They are using customer based data to, understand the customer centric behavior and then use those data to drive their own business. So data related jobs are becoming that famous in the market. Like people are hiring engineers for data analysis, basically analyzing the data, for building the data platforms, which data engineering people will be doing. Then there are data scientists who will be, building models on top of the fetched data, which data engineering people are getting. These models will be helpful to do some kind of predictions or some kind of recommendations for any business purpose. So that's why to carry out any downstream processing of the data should be fetched from different source system in a particular format, in a particular quality, so that it can be directly consumed. These all kind of work is done by a data engineer, right? So I can write here data engineering. It is a concept or a branch of engineering. I wouldn't say a concept, a branch, but I will say it's a concept of engineering where engineers build scalable, secured systems. I would also add resilient, basically a kind of a fault tolerant systems to collect the data, store the data. Number three, process the data. So data engineering is a concept of engineering where engineers build scalable. What is scalable? Anything which can be scaled up, which can be increased or enhanced. So engineers build scalable system, secured system, and resilient systems. Resilient is like kind of anything if it something fails, it tends to bring or go back to its original state, right? So engineers try to build a system which can be scaled, which is secured, secure from any kind of harmful activities from outside, and is resilient to go back to its initial stage in case of any failure, right? So this system is basically meant to collect the data, to store the data, and to process the data. Let me, yeah. So this data, when fetched, is then sent to downstream for further analytical purpose, such as reporting or data science modeling, right? So we'll also talk about the roles or responsibility of a data engineer. So I'll write data engineer short form as DE. make sure whenever I write DE, it means data engineer. So number one is to build scalable system. I have already written scalable word to build a fault tolerant system, to build a private slash secured system, to fetch the data in right format, to fetch the data in, I would say, accurate state. Basically, we're talking about quality or consistency of data over here. Consistency. Then the data is private. Basically, private data means you're not leaking out some confidential information which is used by the companies, right? Number seven, to ensure proper data governance is in place when the data is being fetched and consumed, right? These are the basic responsibilities of a data engineer, right? And to come to the question, so we talk about what is data engineering. I'll now talk about why data engineering. So the short answer will be because of invention, because of invention of internet, most of the devices, I will say most of the devices are running, which produces some or other kind of data. I can say example, your digital watch, right? Your mobile phone. You can take your sound system, right? Your Wi-Fi, which stores your password and your user ID. So all these devices is running on some or the other kind of data. So companies understood that data is new oil, right? For company, data is new oil, which means they want to leverage the data so that they can understand the customer behavior in advance so that they can plan their resources. When I talk about resources, it is both the expenses in terms of manpower or cost. They can plan their expenses or cost accordingly. They can understand how the business is performing in upcoming months, where they need to bring additional workforce, or where they need to invest, basically, or where they need to cut the resources. Basically, where the growth is not happening or where the company is not doing right in terms of business, they want to cut the resources, right? Because for the company the data is new oil, they want to fetch all of this data, and it becomes very important for them to hire right kind of resources, basically data engineers, who can perform this, fetching the data, processing the data, and providing the right kind of data for the end users or for the downstream people so that they can perform the analysis properly, right? And that's the reason, based on this point, because the data is new oil, and because most of the companies have understood, right, like to understand the customer behavior, to understand the trends of how the customer purchases an item in the market, most of the jobs are now turning towards data. Apart from that, there was a major shift which is things becoming digital, basically no need of persons or involvement. During the COVID period, we have seen like people are not going outside, they are buying everything from their home using their phones by using some application. Everything which previously required my presence, my personal presence, now can be done, virtually. All your office meetings you are attending virtually. You can buy any item sitting at your home. You can order food. You can deliver something to some of the friends. Uh, you name something, everything can be done virtually these days, right? Your banking system, your paying your bills, booking a train ticket, booking a flight ticket, everything is now, done through internet. And everywhere, wherever internet is used, data is being formed or data is being consumed by these devices or these applications. So company wants these kind of data to, they want to tap this kind of data so that they can understand where exactly more customers are going, and they can study the trends of the market, and then accordingly they want, you know, to invest in the business. To do all this kind of work, a right mindset or a right resource is required who has to be trained on data. So that's why there's a sudden surge of data related jobs, basically data analyst, data scientist, and data engineers, where people are, started leveraging the tools and technologies to upskill so that they are the right kind of resources for the company, right? So we've discussed what is data engineering, why data engineering, and why the data related jobs are so much of hype in the market. Let me now discuss the difference between a data engineer, a data analyst, and data scientist. We'll discuss this point with a very basic understanding or basic layman example. So I've already discussed a data engineer. Data engineer role is to fetch the data in right format and process it as per the requirement, right? So data engineer, I'll give you an example, right? What is data engineer, what is data analyst, and what is data scientist? Data analyst is a person who analyzes the data by building some kind of reports or dashboards, right? They compare the data source, which is source of truth, with the end or the final consumable data. So basically, they compare the initial data source, the first source of truth, with the end or the final consumable data. Data analysts builds reports or dashboards by using different tools like Tableau, Power BI, and they perform some kind of analysis by using Excel, by using different tools to make sure the data is consistent across different environment. There is no uh, issue in terms of data quality, right? That's the role of a data analyst. They analyze the data to make sure it is consistent across different environment. Now, what is data scientist? I'll give you a random or layman example also, which you can explain in the interview, which can help you to impress an interviewer. Data scientist is a person who performs advanced analytics on the final data to build models for recommendation or for predictions. I'll give you a normal example. Let's say in Amazon, if you go and purchase something today, based on your last purchase, Amazon will give you a different kind of recommendations which he or she can purchase along with that particular item. This doesn't happen for the first time, but slowly, by understanding your purchase trends, Amazon is going to throw some kind of recommendations, basically telling you to buy those products along with these products, right? By doing so, we are going to tell customer like, okay, you have bought so and so product XYZ in the past. It's better if you buy this product along with this product at some discounted price. So these are kind of promotions to the customer to help them buy better, right? Also buy something at a discounted price. At the same time, the company is able to meet their, targets. So data scientist is using the trends or the data of how a customer purchases or performs a purchase in any application. I'm just giving you an example. Based on that data, the data scientists build a kind of model for recommendation of a predictions. For predictions such as, I can give you an example. Let's say New Delhi, in Sector 8, road number 8, there is a lot of traffic. Uh, they want to divert that traffic. So based on some predictory models, they can understand, okay, which lane or which road to be taken so that the traffic or the congestion is not that high, right? To understand all the three examples or all the three roles at a time, I can give you a random example. Let's say your mom has given you a list of items to buy from different grocery stores, right? These items cannot be found in a single supermarket. Let's assume like you have to go to different shops or different vendors across your home to fetch all these kind of items. Let's say there are some 20, 30 items on a list which your mom has told you to buy. So you go to shop one, you find like out of 20, only one or two items are present. You go to shop two, again you find some items, let's say three items. You go to four or five shops and you then complete all the 20 items which are present in the list. So when you're going to different shops, you fetch the item, you compare the price of the item, you see the quality of the item, you see if that is exactly the item which your mother has asked you to fetch, right? Basically, you're checking the format of that item, you're checking the quality, you're checking the expiry date of that item, whether it is correct or not. All these things, what you're doing is kind of a work of a data engineer. You're putting all the items in a basket and you are moving that items to a kitchen. Basically, you are building a pipeline or a system which moves all these items from the shops to the kitchen, right? And you have washed all these items. You have, let's say, you have purchased some fruits or vegetables. You are washing the items. Basically, you are transforming these items. So all these kind of things are done by a data engineer, right? Now, let's say your sister, she is a data analyst. She will check whether your mom has asked you to buy, let's say, hybrid tomato, but you have purchased local tomato, right? So she will analyze, okay, whether the items on the list is exactly the same items which has been, told by a mom to, purchase. So this is the kind of work which a data analyst will do. She will make sure like what all items have been purchased are according to the list, right? Basically ensuring the quality of the data, checking if it is correct or not, checking the availability of the data, right? Then data scientist. Your mom is a data scientist. She will build the models. Basically, she is the end consumption. I can say she's the end consumption of what all items you have bought. It's up upon her what she wants to build, and she will build. Let's say she will build some kind of models as a data scientist. Just giving a random example. So this way you can connect all these three job roles with a normal example. I hope you have liked it. You can explain it in an interview, and basically it is going to impress the interviewer. Now let's talk about the third thing, which is a difference between a big data developer and a data engineer. So if you talk about a big data developer, these jobs were present early in the 90s till 2002, 2005. Uh, this was a time when internet came into picture, a lot of data was being consumed, a lot of data was being produced. Uh, Big data developer basically used to develop all the systems, all those technology to process the big data, obviously. And post 2005, the terminology got changed to data engineering. So if anyone asks you the difference between big data developer and data engineering, data engineer, basically both are the same things. It's like interchangeable words. So just the thing is like there are some kind of skill set here and there which is changing, but the work wise, work is same. So if I talk about big data developer, uh, since this kind of job roles existed across 90s to 2005 or 6, we can say big data developer usually worked on on-premise. I'll explain on-premise in I think model 2. So big data developer they usually work on on-premise, Hadoop, SQL, Hive, MapReduce, etc. etc. But again, the job got evolved with a lot of more new technologies such as Apache Spark. Uh, they worked on Scoop, etc. etc. But yeah, there were more of uh, skills, that day, uh, which helped a person to become a big data developer. But coming to 2006 till date, data engineering word was coined, and the skills which are required are cloud technology. Basically, I'm telling you the skills which I used to differentiate between the two jobs, right? There's no Hadoop, but there is a kind of Spark. Basics of Hadoop is still required. There is Python, there is Scala, and most of the work is coming across cloud technology. So any batch streaming tool, etc., etc. So if someone asks you what is the main difference between a big data developer and a big data engineer, both are same. Just that one is an old kind of job, and that job got evolved into a newer job, which is data engineering, right? So do not get confused. Both are same, like same brothers, but yeah, name being different, right? Now let's talk about point number 4, which is what is big data, how big data came into picture. So for this also, I'm going to give you a layman example to explain what is big data, how it evolved, how it came into the picture, basically why companies thought of a need to classify your data as big data, and then we'll talk about the different 4 V's or 5 V's to classify any kind of data as a big data. So what is big data? As I told, after the invention of internet, many of the devices started running on internet, because of which a lot of data was produced. A lot of data was consumed also by different devices. Most of the devices now are digital. They consume a lot of data. Obviously, when I talk about data, it means internet. And they produce data also, obviously, which is being stored somewhere in the cloud. So when there's so much of data being produced, leave about the processing part. That is the secondary part which companies were worried about. The primary issue, the company was thinking how they can store this huge amount of data. If you remember, when we were small, there used to be cassettes, video cassette or tape recorder cassettes, which we used to use to play music or to watch a movie. Then came CDs, then came DVDs, then pen drive, hard disk, external hard disk. Now we are using cloud. So company understood, okay, the major issue is storing the data, because data is coming from different devices at different rate, frequency. So processing is the second part. First part is how we store it. So that's where they realized, okay, they need to have a kind of a framework or a technology which can store this high evolving data. So that's where when big data came into picture. So in 1980s or 1990s, I'm not pretty sure of the date, but yeah, this big data came into the market. People started realizing, okay, there are some data which is of very high size, huge volume capacity. It can come at any different rates, and we need to store this kind of data, so that if we process it, we are going to get some kind of return. But processing was not the major issue. They wanted to store this data so that they can retrieve it. Let me give you an example. If you go to a library, previously we used to maintain all those big registers, right? Who is purchasing which book or who is taking which book when they're going to return. So whenever you used to visit a library, they used to see those big registers. Now think of an current time where all this data is sitting somewhere in a database. I need not maintain all this register, right? But this is a very huge ton of data. So instead of me maintaining all those manual registers, I can store it somewhere in a software, in a database. I can retrieve them as per the need, right? So company realized, okay, let us have a kind of technology where we can store this huge amount of data, which can be processed further depending upon the need. So that's when big data came in the market. So any data, let me write about big data. What is big data? Any data which cannot be stored on conventional system is called as big data. When I say system, it means conventional systems means uh, CDs, DVDs, drives, etc. Any data which cannot be stored on conventional system is called as a big data. Big data came into the picture because of high usage of internet. A lot of data got produced, so company realized, okay, we need to store this data. Now let's talk about what are the four V's or five V's to classify any data as a big data. So four V's, or it got recently changed to five V's of big data. We are going to discuss each one of them one by one. Number one, volume. Number two, velocity, variety, veracity, value. So volume. If the size of data is so high that it cannot be stored in a single system, or it cannot be stored in a conventional system in a conventional manner, so that kind of data can be classified as a big data. So when I'm talking about volume, these volume means petabytes of data, or it's like trillions of data. So when volume of data is so high that it cannot be stored in a single system, that means I need to term that kind of data as a big data, right? When volume of data being produced is very high, that it becomes difficult for us to store it in conventional system, then we need to classify that data as a big data. Okay. Now let's talk about velocity. So if the volume of the data is very high, then obviously I cannot store it in the conventional devices or systems. I need to have a new system, a new technology to process and store this kind of huge volume data, right? That's I'm terming that kind of data is a big data. Now let's talk about velocity. The rate or the speed at which this data is coming. If the rate is very high or the speed is very high, then also I need to classify this data as a big data. For example, if I go to any supermarket and if I swipe my credit card, you see within seconds of a time, after I swipe my credit card, I get a message in my system, in my phone basically, that some amount has been deducted. Same message on the phone goes via email on my email ID as well. So whenever a transaction is happening, there is a messaging queue being triggered, alerting me that some transaction happened. Basically, a amount got deducted from my account. The same amount went to merchant, and the merchant will be notified as well, right? So all these messagings, all this velocity of data transfer happens so fast that we need a big data processing system for the same kind of data. That's why any system which produces or consumes data at high frequency to process or store such high frequent data, we need to have big data system or framework, right? Now let's talk about variety. Data can be of different variety. It can be structured, semi-structured, unstructured. A data which can be stored in the form of tables is called as a structured data. A data which is not exactly structured, uh, where a schema cannot be attached to it, It can be called as a semi-structured data, example, your JSON, your XML. Data which are like completely unstructured, which I cannot store in a structured format. For example, my audio clip, my audio voice message, or any video message, basically are unstructured data. So data is present in a different format across different areas. So I need to bring all this data on a single common platform and make sure the data is in a consistent format. So whenever the data variety is different, so I can write like if the variety or structure of data is changing, that means that data has to be classified as big data. So if the data is present in different varieties or in a different format or different structure, we need to classify that data as a big data. So what is veracity? So veracity is mainly talking about the consistency or quality of data, right? If the consistency or the quality of data is changing from layer to layer or from environment to environment, basically one data in one environment looks different. So to process those kind of data also, I need to have a big data system or a big data environment. So that kind of data again is called as big data. So basically, if the data quality or consistency is changing based on layers or environment, then the data can be classified as big data, right? The final point, value, it was coined very recently. I'm not sure when, but yeah, value is to make sure whatever data we are fetching, the end data, that should be of very high value. It shouldn't be a case like we have fetched a lot of data from different system, we have transformed it, and then we realize that the fetched data cannot be leveraged or cannot be realized to get a beneficial output, right? So we need to make sure if the data which you're fetching is of very high value, then we need to classify that data as a big data, right? If the data being fetched is of high value, then also we can classify that data as big data, right? So we have understood what is big data, uh, how it came into reality, and what are the five B's to classify a data as a big data, right? Now let's go to point number five, which is skill sets required to become a data engineer in 2024 and how can I move from these roles to data engineering. Let me talk about it. I might be using Paint for it somewhere, but yeah, we'll discuss about it. This is question number four. Let me skills. So there are n number of skills required to become data engineering. Mastering few of them will help you down the line. So we'll start with basic SQL, database, basically RDBMS, right? We'll talk about ETL concept, extract, transform, and load, or ELT concept, extract, load, transform. We are going to discuss the difference between these two in model 2 basically. Uh, then we are going to talk about cloud concepts, right? Basics of big data such as distributed processing, parallel processing, distributed system, etc. etc. Then sometimes you need a data modeling concept or a data warehousing concept. Then you need data structures slash algorithms. So a person should understand which format or which structure of data should be used to store the data. It can be a list, it can be a dictionary. So depending upon the use case, the person should have the knowledge how the data has to be stored. So that is one more thing. Then For stream processing, we have tools like for stream processing, I can write tools like Kafka. We have skills like Azure, Data Factory. It's an ETL tool. Again, it depends upon the cloud. So I need not write it here, but yeah, cloud tools I can write. Above was cloud concept, and this is cloud tools and technologies, right? You need Spark, Apache Spark, very, very important. So I think these are the, you know, major skill set which every data engineer should be knowing. Again, depends upon the depth you want to go, but yeah, most of the time these are the skill sets which are required or which are basically asked in the interviews, be it a normal company to a Fortune 500 company, right? Now we're going to talk about how a person from any domain or from any skill can, you know, move from a data analyst role, a business analyst role, or a DBA role to a data engineer. I'm going to explain you thoughtfully how one can move from these roles, right? Let me take a paint. Let me take a new file. Don't save. I'm going to draw a Venn diagram basically, uh, which will help you to visualize or understand. Let me take another circle, put it over here, right? This is DE, which is data engineering. This is data analyst or business analyst, let's say one of the same. Data scientist, data scientist. Okay. We can take one more circle, a smaller circle, which is a DBA. DBA is more towards uh, data analyst or business analyst kind of work. But yeah, you can visualize like this small circle. I can write here a DBA, database administrator, right? For data engineering, let me expand this and let me increase the font size so that it is visible. Data engineering. I hope my size is good. If not, I'll increase further. Data engineering, I have told you the skills. I'll just copy and paste the same thing. Okay, right? Data analyst uh, is basically SQL, Python, cloud these days, little bit, yes, cloud concept, Excel, advanced Excel. Excel sometimes is also used in data engineering. Excel is something which is used across all the job roles, so I need not mention them, right? Power BI or Tableau, right? I can write here a data engineering is DE equal to DA, basically data analyst, plus additional skills, right? So if a person wants to move from data analyst to data engineering, these skills he or she should know. On top of that, the additional skills, whatever you have mentioned here, if they can learn, they can move from a data analyst to a data engineer, right? Then who is a DBA? A database administrator should know SQL, should know RDBMS. Sometimes they know scripting language such as Unix or Linux, right? They know cloud concepts these days, right? So these are the major skills of a database administrator. They majorly work on on-premise, but yeah, depending upon the company to company, they might change from on-premise to cloud. Uh, DE is also equal to DVA plus additional skills. A DBA can also become a data engineer provided he or she learns all those skills which are required, as I have mentioned above. So, data engineering already knows these things, but on top of that, what are additional things they need to learn so that they can, you know, start appearing for data engineering roles or the interviews. Now comes data scientist. So, few of the skills for data scientists are different. I like them. So, SQL is important again. Python is again important. They also need mathematical skills such as statistics. What happened? Statistics, probability, linear algebra, calculus, etc. etc. Then they need to know reporting sometimes, sometimes not majorly. They should know R, right? That's the major thing, and cloud concepts obviously, because they are also working on cloud concepts or ETL, ELT. They should also know, right? So if a person from data engineering background, obviously they have more skills. If they can learn this mathematical skills, on top of that, they need to know predictions, prediction analysis, modeling, or building models, basically building AI ML models. So artificial intelligence is another concept for data scientists. Machine learning is another concept for data scientists. If a data engineer wants to move to data scientist, uh, apart from SQL, Python, and cloud concept, they have to learn the rest of the other skills. I hope I have given a holistic difference of the skill set based upon different roles, based upon different expertise. I hope this chart or this Venn diagram is going to help you. Majorly, if you see this color, which I can highlight this is the part which is SQL, Python, some kind of reporting tools, which all the job roles are required, to upskill with. So you can start targeting those skills, and then slowly you can learning more skills in technology as per the job role. Let's go back to our discussion, which is module one of data engineering. Okay, we have discussed skills which are required to become a data engineer, and then how can one move from these roles to data engineering. Now let's go to question number 6, and this concept will help you cement your fundamentals on big data or data engineering. Let me write it over here and let's move to the top of the page. Again, I'll be using Paint to explain you in a diagrammatical fashion the difference between monolithic system and distributed system. So monolithic system is like traditional system. These are called as vertical system. You can scale up vertically by adding more resources on top of the system. You can increase the storage by getting more RAM, more CPU. That's where monolithic system came into picture. But distributed is something different. So let me not waste much time. Let me open my Paint and show you practically. Let me take a new window and save it. I'll take this as a monolithic system and this one as a distributed system. So in an interview, you can always, you know, and remember the drawing and you can explain them easily, right? So let's say this is my initial system. So let me take this as A, B, C, D. So initially my system has some kind of RAM. RAM is basically random access memory. It's a kind of a storage. My initial system A had a lot of data, and beyond which now it cannot be scaled up. And because of the performance issue, I have decided, okay, I need to scale the system. So I bring some additional resource on top of A. Now this becomes, I can write here as, here I'll write something like A plus B, right? So these two systems together becomes one system. We have brought in additional system to get more storage, to get more compute. Now let's say after a certain time, again, my threshold limit has been reached where I can't scale up. So I bring another system, on top of A plus B. So now it becomes A plus B plus C. A plus B plus C. Basically, I have bought in additional resource to increase the storage, to increase the compute, right? And as the data grows, again, obviously A plus B plus C will reach its threshold. And then again, I decide, okay, I can bring some additional resource or storage to accommodate the increased capacity. Then now it becomes A plus B plus C plus D. But this adding additional resources can go up to a limit only. Because after a certain stage you see, okay, you keep you keep on adding resources or storage, but after a certain time there's not much performance benefit or performance gain, right? So this system mainly I can classify it as a monolithic system or major traditional system. Monolithic system. Expand this. This is distributed system. I'll give you a good example which you can remember during your interview. So distributed system. Okay. Uh, I can call this entire architecture as a distributed architecture or a worker slave architecture, right? So parent child architecture also you can call worker slave architecture. It's upon you, whatever you want to call, you can call distributed architecture basically, right? So let's say I had some kind of work to be performed. Let's say X is a work to be performed. I'm distributing the work X between the different workers A, B, C, D, and E. So all these worker nodes A, B, C, D, and E are working parallelly. So a part of work is submitted to A part of work is submitted to B, and so on and so forth up to E. All these workers are live, working together parallelly, splitting the work between themselves. The output of all these worker nodes is again combined to get X. This kind of architecture we call it as a distributed architecture, right? So obviously in this system, not everything is being worked parallelly because all the work is done simultaneously by a single system. But here, the same work is divided between the number of resources. It's just like a project. In a project, one project is divided between the resources based upon their bandwidth. So to produce X work, I'm dividing that X work between 1, 2, 3, 4, 5 workers. And all these workers are working parallelly. The output of all the workers will be combined together to get the final result, which is X. So this kind of architecture is called distributed architecture or parallel processing architecture, right? MPP is again one of the concept, massive parallel processing, which we'll be discussing in module 2 of data engineering, right? This kind of architecture is called a distributed architecture. So best example I can give you is Indian wedding. Let's say you need to cook food for around 500 guests, right? So you ask some kind of caterers, you order a caterer to cook that food for the guest. So there will be a master chef uh, who will have, let's say, 10 to 15 workers below him. Some workers, let's say two, three workers are cutting vegetables, two, three workers are preparing some sauce or some item which has to be, garnished with the vegetables. Some workers are cleaning utensils. Some workers are putting the fire or the stove or making the stove ready. Some workers are only to stir the vegetables once it is, put in the pan. So all the workers are working together for the end result. And finally, the master chef. Basically, this master chef or this master node. These are worker nodes. This is called master node. The master node checks how the other nodes is working, or he checks or manages the task, whether the worker node is performing his or her task properly or not, or whether the worker node is alive or not, basically performing his day-to-day operation, right? So this kind of architecture, uh, which I have given you in the example of a master chef and the workers below him, can be called as a distributed architecture, right? Master chef will basically go and taste the final output just to understand, okay, whether the cooked food is very good, if it can be served or not. So this is the major task, to manage, to check how the workers are working, if they're working properly or not. It's a kind of a work done by a master node. Let's go back to the slide which we have prepared. So we have talked about the difference between monolithic system and a distributed system. Let's go to question number 7, pay scale of modern data engineers. So there's no standard answer for this question, but yeah, 2023 result I can say 2024 has just started. So on average, we'll talk about average figures on average and based upon the average experience on average for 3 years experience guy in a Fortune 500 company, the pay is 17 LPA. This is the average pay of a 3 years Fortune 500 company resource. But again, if it's a service company, 3 years, it is around 11 LPA. Basically, these are for service companies. I'm talking about a 3 years experience. So more the experience, more the pay. It again differs from company to company, the brand or the rank or which designation you're going. So data engineers, there's a proper designation also. There are designations like associate data engineer, data engineer, senior data engineer, uh, principal data engineer, data architect, etc. etc. So associate data engineer up to 2 years, 2 years, data engineer 2 years to 3 years, senior anything 4 plus to 7 I can say, 7 years. Some companies like Facebook, Amazon, Google, it again changes. Senior data engineers like SD2, SD3. Principal data engineer, uh, 11 plus to 15, right? Data architect again, 8 to 15, depends again company. Roles keep on changing, but I have given you just an average figure for a 3 years experience guy. Again, with the experience of with based upon your past salary, based upon your previous brand of the company, the salaries can vary. So there's not a fixed salary, but yeah, the trends for the freshers or for the 3 years experience resources in the market, the trends are good, the packages are good, right? Let us go to the last point, which is point number 8, emerging trends in the market post Gen AI for data engineers. So I keep hearing from people asking me these questions that, hey Aditya, will there be job cuts for data engineers in the market? So there won't be any job cut. Uh, Generative AI will basically make our lives much more easy So a data engineer can easily use tools such as GenAI to improve their current existing systems, to change the code or logic or build some kind of enhancement on the current system. So it's a kind of a calculator which you can utilize to enhance your current calculations, right? So for data engineers, GenAI can be integrated with some systems which are previously built to make sure the solutions whatever you're using are using some generative AI models output to understand whether the current systems are performing well or not. You can take some kind of help from Gen AI models to see if the fetch data can be made much more better. If you can enhance the system which can fetch data easily or at a high speed or a high velocity. You can also check if the data which is being fetched is applying all the data governance rule, making sure Gen AI has enabled, best practices for the engineers to follow. So all these trends which are emerging because of Gen AI in the market can be integrated with data engineering, which can help a data engineer to perform his or her work properly. It is not uh, going to cut jobs, but yeah, the mundane task which a data engineer does, that can be removed, that can be made little bit, reduced. But yeah, most of the times we need to figure out, okay, how we can enhance or how we can enable some additional advantages by using Gen AI, making sure whatever system we have built or which we are going to build in the future, it is better than which we are building right now, right? So Gen AI can be used there. We are still not sure how it can be integrated, but yeah, there are some research going on, and people will be coming out with some kind of solutions, which obviously data engineers will be applying. So we have covered all the 8 points today in this module 1 of data engineering. I hope you would have liked the session. If there are any questions, please do not hesitate to ask, but I hope you have enjoyed the session. Thank you very much. We'll meet again in module 2 of data engineering.
I hope everything is clear. If you have enjoyed watching this video, please do like and subscribe to Scalar's YouTube channel. If you want to watch similar content in future, do not forget to subscribe to Scalar YouTube channel. Thank you for watching this video. We'll see you again.